Welcome everybody to this topic of statistics hypothesis testing step 4. Formulate a decision rule, one-tail versus two-tail test. Before we continue, let's remind ourselves what a hypothesis is. Hypothesis is a statement about the value of a population parameter like mu, which is a population mean, or sigma, which is a population standard deviation. That has been developed for the purpose of testing. Hypothesis testing is a procedure based on simple evidence and probability theory to determine whether the hypothesis is a reasonable statement or not. This particular step for this video is step 4, where we formulate a decision rule. A decision rule is a statement of the specific conditions under which the null hypothesis H0 is rejected and the conditions under which the H0 is not rejected. For us to figure out these two regions that reject and not reject, we need to figure out our critical value. The critical value is the dividing point between the region where the null hypothesis H0 is rejected and where it is not rejected. So there are 3 cases for this rejection and rejection section. The first case is where we check for the lower tail, and we'll see when that happens. Another case is when we have 2 tails. And the third case is when we look at the upper tail. Once we figure out which area of the curve we're testing, we move on to step 5, which is a different video for you to review. And in this step 5, we calculate the test statistics, either the t of the sample or the z of the sample. This is according to the step 3, in which you need to decide which distribution you're using, whether the t or the z. Either way, you calculate the test statistics and then you compare it to this critical value. If you were to be in an area that is or a critical value, I'm sorry. Once you calculate your t or your z sample, if you are getting a t or a z that is bigger than your critical value, then you reject the H0. Or if you're in an area in which you are lower than your critical value, then you do not reject your H0. Yes, for the first case, if the t or z of your sample is lower than or more negative than your critical value, you reject. If your t or your z statistics is bigger than or less negative than your critical value, then you do not reject. So either way, the step 4 is giving you the areas of rejection and not rejection. So it's a very important step. So let's see the first case. The one-tail test on the upper region or your right tail. This happens when your H1, your alternate hypothesis, is being tested for an area in which you are bigger than your mu or your sigma. So when you're checking your parameter, that whether it is more than a particular number. So when you have more than, you see the sign more than is basically giving you the direction pointing towards the upper region. So now this area here is defined by your alpha. The alpha is the step 2 of hypothesis testing and is normally given to you on the exercise. The alpha is the level of significance. So let's assume they give us a level of significance of 0.05. So 0.05 is the area of rejection. Okay, so alpha signifies the area of rejection of H0. You're always testing for H0. So if you have H1 testing for more than, then you're on the upper area. And the upper area, your rejection region, is equal to the alpha. For this particular exercise, the alpha is 0.05. So the area of not rejection is 1 minus alpha. So 1 minus alpha, 0.05, I'm sorry, 0.05. Don't skip zeros there, it's 0.095. So this area on the right side of your alpha is the area where you do not reject your H0. Now, these two areas, the rejection and not rejection, are separated by the critical value. In this particular area, let's assume we have decided on step 3. Step 3 is where you decide whether you're doing the Z or the T. So in the third step, you were able to decide that you were doing the Z scale. So now we need to get the Z value that separates this rejection zone from the do not rejection zone. Now, if you're using the MegaStat, then MegaStat tells you the Z value that separates these two regions from. So let's go. For this particular diagram here, we get to see that the critical value is 1.65. Let's go and figure it out in MegaStat. Where is that 1.65 coming from? So let me get out from here. And MegaStat is, for my computer, is under data. So data, MegaStat, you do probability, normal distribution. And you're trying to calculate, you have two choices here. Calculate P given a Z, or calculate Z given a P. P is for probability. Probability is the area under the curve. So by default, it gives you 0.05. So we don't need to change it. Since we're looking at calculating the Z has always in the middle is 0, and every standard deviation of Z is equal to 1. So you don't have to move any of this. You just have to type your your alpha value, your level of significance in the area, so on the P. So we're looking for an area of 0.05, and we're looking for an area on the shading section. You have two choices, lower, upper, or two tails. We are looking for the alpha, the area of 0.05, and the upper tail, so shading upper. That's the only thing you do. Then you click OK, and it tells you here. Let me move this forward. Okay, let me make this smaller for you to see. And we are looking at this upper area here. Is this upper area here 0.095? The Z statistics, the critical value is here 1.64. You know, on our slide it said 1.65. Well, let me get this out. If I come to this 1.64, the number is actually 1.644853. You know, it has many digits. So actually the slide is 1.65 because it was rounded up. Okay, from here we use the critical value here is 1.64. Now, just to confirm, the lower area, okay, this section here is this section here, 1.95. So the area from here is 0.05, which is this one, and the area on the opposite side is 0.095. When we go to step 5 and we calculate the Z of your sample, which is going to be X minus mu divided by sigma square root of n, when you calculate this, you get to compare the Z value that you get, whatever it is, to your critical value. The critical value is 1.64 for an alpha of 0.05 and a lower tail of 1 minus alpha, which is 0.095. So we go back into our PowerPoint and we get to see that this critical value, the Z value that divides the upper region an alpha of 0.05 to a lower region of 0.095, the lower region is the area where you do not reject the null hypothesis H0, is equal to, well, in our MegaStat we saw 1.64, 4, you know, many digits. So in this particular slide, it was rounded up to 1.65. Either way, whether you use 1.64 or 1.65, that is your critical value that separates the reject zone for the do not reject zone. This word here is value, by the way. I'm seeing that it's misspelled. All right. So now, the second step, Or the second case, you need to figure out which case you're using. The second case is when you're testing on the lower tail, the one tail lower region, or the left tail. This is when your alternate hypothesis is testing whether your population mean or your population standard deviation is testing for less than. See where it's pointing at. It's pointing towards the left. Once again, you're looking at an area on the lower region if you're doing less than, and the region of your tail region will be your alpha area. The alpha area is the level of significance. Let's assume it gives you again an alpha of 0.05, which means the area of the do not reject age 0 is 1 minus alpha, because they complement each other, which means 1 minus 0.05, which is 0.95. And we need to figure out the critical value, the line. Again, we're looking at the Z table, because on step 3, we then have decided that we're using the Z value. And if we're using the Z value, we need to figure out the Z value that separates. What is this one line that separates the do not reject H0 from the reject H0 zone? The alpha is the area of rejection. So let's go and check it out in MegaStat. What is this critical value? From the one slide before, the upper area of 0.05% had a Z of 1.65. This is a critical, the curve is symmetric. So if the upper area is positive 1.65, then the lower area will be negative. But let's go see it in MegaStat. So let's see, ladies. MegaStat. We go data, MegaStat, probability normal distribution, and we're going back to the 0.05 because that's our alpha, but we need to tell MegaStat that we're looking at the lower tail. Okay, you have 3 choices again: lower, upper, 2 tails. So lower tail. I'm going to unclick overlay because I want a different curve. This overlay means if you click it, it means that it's going to use the same curve as before. And as you can tell, the curve here is, it has a lot of writing, so I'm going to create a new curve. I unclick overlay. So I say, okay. There you have it. So we are looking at a lower tail with an alpha equals to 0.05, and that means that your upper tail is 0.95. So alpha is the area of rejection, and we're always rejecting H0 or not rejecting H0. The area opposite to it is 1 minus alpha, which is 1 minus 0.05, which is 0.95. Always check your areas. If you type something wrong, you can check there. And the line, the critical value that separates this rejection area from the do not reject H0 is a line, a Z of 1.64 negative. The one exercise above, it was, let's go up. Yes, it was in the upper line, and therefore it was a positive number. And when you're testing the lower tail, you should be getting critical values that are negative, because the Z from the middle, okay, I'm not sure what's happening here. Okay, MegaStat has refused to work. This happens too. You need to be ready for everything, ladies and gentlemen. So this line to the middle, you see? This is fun. Okay, here we go. The Z from the middle to the lower tail is always negative. The Z from the middle to the right tail is positive. So in this case, we're getting a negative 1.64. Again, our slide here is rounding up, and that's where we get Z that is negative 1.65, where it's actually negative 1.64 with many, 1.644, many different digits. So in this particular slide is rounded up. So this is where we have the region of rejection, which is the area of the alpha, and the opposite side is 1 minus alpha. Okay, the third case is your two-tailed test, where you have when you're testing for equal and not equal a number. So when you're reading your exercise, particular problem that you're looking at, and they're testing for whether a number is the same or has a change, is it different from, those are keywords for equal and not equal. The equal sign always goes on the H0 hypothesis, and the alternate hypothesis is always not equal to, or the opposite of whatever H0 is. So if you have not equal to, then you have two tails. Okay, two tails. And when you have two tails, then basically you have if you are going with the same alpha of 0.05, since you have two tails, then in this case the alpha has to be divided by 2 because you have two tails. Now in this case we have the slide here telling us that the critical value is equal to 1.96, positive and negative because this is symmetric, right? So you have your alpha separated by 2 or divided by 2, which means 0.05 divided by 2, and that's equal to 0.025. 0.025. That means that the area in the middle, which is the area of do not reject H0, is again 1 minus alpha. They are complementing each other. So it's 1 minus 0.05 and it's your 0.95. So critical value is not 1.65 as before, it's 1.96. Let's figure that out into MegaStat again. So let's check it out. You have data, MegaStat, probability, normal distribution. Once again, the alpha is here 0.05, but I'm going to tell MegaStat that is two tails because it's equal and not equal to, and I'm going to on-click the overlay. I want a fresh, brand new curve. So let's do it, and there you have, this is our two-tailed test, and let's see what it's telling us here. So you have this tail here, and this is my upper tail, and you see the numbers are bolded, and the lower tail is this one here. It's 0.025. So this area here is alpha divided by 2. Alpha was equal to 0.05. So that's in total. Since I have two sections, I separate my alpha by 2. 0.025. I'm sorry, 0.05 divided by 2, and that was 0.025, which is here and here. So this is alpha divided by 2, 0.025, 0.025. And the area in between, which is my area of not reject, H0, my alpha is always, wherever your alpha is, upper, lower, or in the two tails, the alpha is always the area of rejection of H0. All right, so the line, my critical value, the critical value, okay, the CV, the line that separates these two regions is 1.96 positive and negative. This is symmetric, and this is on the Z scale. You can see here, there's the Z scale. If you were to do the T scale, I'll show you quickly here. If in step 3 you decided to do T statistics, you do probability, normal distribution. Oops, I'm sorry. Cancel. Probability, and instead of normal distribution, you go to the T distribution. In here again, your probability is your alpha, so you figure out what your alpha is, and you have to do the lower, upper, or two tails according to your case. But for t-distribution, you have to give it the degrees of freedom. Degrees of freedom is n minus 1. So let's assume n, your sample size is 30, for example, 30. So degrees of freedom, df, is 30 minus 1, which is 29. So degrees of freedom, you always reduce your sample size by 1. And let's assume it's a two-tail here. Let's see how this is different. So this is for an n equals to 30. Degrees of freedom n minus 1 is 29. And an alpha of 0.05. The p is always here. You just have to put one more step if you're doing t, n minus 1 degrees of freedom. And let's compare it to a two-tail. Let's see how this is different. So here, if you had a t-tail, t statistics instead of z statistics, the t-value will always be bigger. Okay, the t distribution is always shorter and wider. So you see here, for an n equals to 3, we get degrees of freedom n minus 1, which is 29. And we get that the critical value, the t-test, the t-value that separates your do not reject H0 from the reject H0, and you have two tails. We're doing the two-tail test, is positive and negative 2.045. If you had decided on step 3 to use the z-table, then that critical value is 1.96 positive and negative. If it is a t-value is bigger than that, it's 2.045. So this is how step 3 is very important. It helps you decide whether you're using t or z, and that's where you go on MegaStat and you figure out whether you do data, MegaStat, probability. Are you using the z-table? You do normal, and you figure out, this is, you're calculating the z even at p. This is where you put your alpha, and then you figure out which tail you are testing, the lower tail, if your H1 is lower than a number. You're using your upper tail if your H1, your alternate hypothesis, is testing for greater than a number. And you're doing a two-tail test if you're doing equal and not equal to. Now, if your step 3, you decided to use your t distribution, then you do MegaStat probability, and then you do t distribution. And on the t distribution, you need to figure out your degrees of freedom. Okay, your degrees of freedom is n minus 1. That's the extra step that you do from the z distribution. Sample size is very important for you to know when you're doing the t distribution. Okay, and this is why we get on a z distribution the critical value of positive and negative 1.96, because we have divided our alpha by 2. Okay, so just a summary, we have 3 cases when you're doing step 4, and you have to figure out which of the 3 cases you do. If you have a alternative hypothesis, which is H1, and you're doing more than, then you're testing the upper tail. If your alternate hypothesis is doing less than, then you are testing the lower tail. If your alternate hypothesis is testing for equal and not equal to, then you have 2 tails, and that means the area of your tails is alpha divided by 2. If you only have 1 tail, then the area of rejection is the full alpha. Okay? From there, you go to step 5, which is a different video, but you do your test statistics, the step 5, and you calculate either your Z or your T according to your step 3, and you figure out whether this Z or this T is bigger than your critical value or lower than your critical value, and if your lower tail is the area of rejection, and if you are in any of your tails, then you reject the H0. If you are bigger than your tail than you are on the area of not rejected. And that finishes the step 4, which is formulation of the decision rule. Hope this helps. Have a great day, and thank you, everybody.